1/12, correct? And I put on the weighing scale. Then I took atoms of sodium, 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 and that many atoms of sodium came in level with the weight of 1/12 of carbon C12, not carbon C30, not carbon C90, but carbon C12. Okay, that means this weight, these many atoms, their weight is equal to the weight of C12. C by 1/12. C 1/12. Okay. Now you know what the weight is. You know the weight is, suppose it is 100 grams. Suppose it is 100 grams, all right? And these are about, say, 90. So this divided by 90 will give you the weight of 1. Follow? Is this clear? That is how we approximately calculated the weight of one atom with respect to a standard called carbon 12. Is this clear? Carbon, that is why it is in relation, so it's called relative atomic mass. We're finding all the atoms, correct? So what we do is we took one watermelon. That is one atom of carbon. That one full watermelon. We cut it into 12 slices. We took one slice, that is 1/12. We put it into this weighing scale, and then we added and added and added and added, and then we found that number of, say, sodium atoms, that weight of the sodium atoms was equivalent to the weight of 1/12 carbon 12, 1/12 of carbon C12. Okay, count the number of atoms here. Just count the number of them. Divide this weight by this number, and you'll get the weight of one atom. That is by relative. So what is relative atomic mass? Relative atomic mass, in short, we'll write down RAM is equal to mass of one atom of an element upon 1/12 the mass of carbon C12. 1/12 the mass of carbon C12. That is called your relative atomic mass. Followed so far?
There is 1/12 mass of C12 will be same in every condition.
Yes, you always have to take that as a standard. And it's easy to handle. Why would it? You want to take 1/30th? Just take the minute. It's a standard. Easy to handle. And this answer is whatever. And the answer is equal to whatever answer you get. Suppose you get answer X. That X, the unit is atomic mass unit. Atomic mass unit, which is AMU. This, what should I say? Not mass. Well, it's this. It's not grams. It's atomic mass unit. Or we would say unified mass, or atomic mass unit is called unified mass. Unified mass, or U. So this RAM, okay, it's unit. The unit is not grams. The unit is atomic AMU or U. That is the unit. It is not grams. It is U. All right. U is different from grams. Now, so therefore, I would say one carbon atom, okay, mass is equal to 12U. One oxygen atomic mass is equal to 16U. Correct? Oxygen. Then you can say one hydrogen atomic mass unit is, say, what's it? 1U. This is 16U. Okay? If I say, give it to me in grams, then you just write down 12 grams, 16 grams, 1 gram. If I say, give me the answer in grams. If I say in unified mass or U, the same number. The same number. Correct? This is clear? Now, how do we know what is the value of this U? How do we convert U into grams? That is find out the value of the U, exact value of U. In the case of carbon, first of all, we know we'll say this is AMU or U, correct? I want the space, so that's why. Now what I'm saying is, if I say the mass of one atom of carbon, okay, if I say the atomic mass, if I say the atomic mass of carbon is 12 grams, how many atoms are there? If I say atomic mass of carbon is equal to 12 grams. How many atoms are there in this? In the 12 grams, how many atoms are there? Huh?
Sorry.
No, not 12 atoms. You have Avogadro's number. Have you heard of Avogadro's number? What is it? It's a what? 6.022 into 10 raised to 23. These many atoms are giving you 12 grams. Okay, atomic weight. When we say atomic weight of carbon is 12 grams, okay, we mean that these many atoms weigh 12 grams. Correct? So therefore, how do we find out the value of one atom? This divided by 6.022 into 10 raised to 23. The answer is of one atom of carbon is actually 1.9926 into 10 raised to minus 23. The 23 goes on top. So it goes on top according to your indices, law of indices, it will become minus 23. When you divide these two, you get the value of one atom. So one atom of carbon weighs so much. Then what is 12? 12 is a weight of 6.023. 12 is a weight of 6.02. 16 in the case of oxygen is a weight of 6.023. Okay? 1 is a weight of actually so many atoms of the particular element. Avogadro's number. Avogadro's number is the number of atoms present in the atomic weight of a particular element. Now, if I want to find out the value of U, U is not grams. U is another unit completely. What is the value of U? In the case of carbon, we have got here 1.9926 into 10 raised to minus 23 divided by, you have got 12. You've got 12 divided by 1.9926 into 10 raised to minus 23. Okay, when you divide this, okay, you get 1.6605 into 10 raised to minus 24. This is the value of U in the case of carbon. In the case of carbon. So if you want to find out the value of U in the case of oxygen, find out the weight of one atom of oxygen and divide that weight by 16. Correct? If it's an oxygen. So first of all, how do you find out the weight of one atom of oxygen? 16 divided by Avogadro's number. Yes or no? One atom of oxygen, how will you get it? 16 divided by Avogadro's number. You get that answer, okay? Then 16 divided by that answer will give you the value of one atom of oxygen. How many of you have understood this? Raise your hands. Yeah, what did you understand? Did not understand. You understood. You know the calculation. All of you? Yeah.
Ma'am, so that can we call that 12 grams 1 mole of
You don't go into mole now. Leave it. That's a concept. You're not wrong. But until unless I explain to you the deep, basic, don't jump into all that. Okay, please go with it. So you got this much now. All of you follow this. I'll revise it at the end of it. Okay. Now we come to relative molecular mass. What is relative molecular mass? Same thing. Same thing. Only thing is instead of atom, you will put molecule. You put molecule. That's all. So relative molecular mass RMM is equal to, come on, say it loudly, mass of one molecule of a, how can it be, how can you have a molecule of a substance? Yes or no? The Bible said molecule. Bible said element. Huh? Because the book is open. Shut that book. Shut that book. Shut it. So smart you laugh. Huh? Got it now? Same thing. Molecule is of a substance. And element, and atom is of an element. Correct? Upon, come on, now this you can say, upon 1 by 12 mass of carbon C12. That is it. Again, this is in unified mass. Again, this is U. Again, this is U. But if I say, give it to me in grams, change the U to GRMs. That is all. Is this clear? Followed now? Yeah. Now, after we've done, okay, now can you read that much? What has up to here you read? Don't touch relative molecular, don't touch calculations. Don't go for molecular, just read relative atomic mass. And don't go, and what is in that box, in the box? In the box you read. Where's your book? Textbook. Why have you come to class without a textbook? Where have you come from? From home or you come from where? From? You don't open your bag and check up what books are there in the bag? Huh? What happened? I didn't hear you. You don't know where you have kept the textbooks. You want to continue in this class, Ian? Yes or no? You have to change your attitude, okay? Umpteen times I told you, don't ever enter the class without a textbook. How do you expect to learn? This one. This one. I'll come to it again. Pay attention, first of all, relative atomic mass. I told you why it's called relative, because it is with respect to a particular element, which is taken as a standard. Why do we have to do that? Because we cannot find out the weight of one atom on its own. We have to find it out in comparison to something else. And what is the something else? The standard. The standard was taken to be carbon. Why carbon? Because carbon gave us positive whole numbers. We tried with oxygen, we were getting fractions. We tried with chlorine, we were getting fractions. If we tried with hydrogen, we were getting fractions. But what was giving us whole numbers in most cases? There are always exceptions or rules. Remember that. Generally speaking, we were getting whole number ratio, whole numbers, because we were dealing with carbon C12. Okay. Now, what is the meaning of that? Carbon C12 means one atom of carbon we cut into 12 slices. And we took one of those slices and we made it 112. And then, with respect to the weight of that 112, we found out the weight of the corresponding elements. Okay? And then, dividing the weight by the number of atoms of the element, we found out the weight of the single element. And that is how we got this particular ratio, that RAM is nothing else but mass of one atom of an element, okay, upon 1/12 the mass of carbon, C12. Okay, that unit is said to be atomic mass unit or unified mass, which is U. It is not grams. Okay, so therefore now we find that one carbon atom, the mass is 12U. The mass of one carbon atom, the mass, not the weight, the mass. What is the difference between mass and weight? When you're on Earth, you've got weight. Now the weight is mass multiplied by gravitational pull. When you are in space, you've lost gravitational pull. There is your weightless. But have you got mass? Yes. Have you lost your mass? No. Your mass is still there. What have you lost? Weight. Because weight is, there's no gravitational pull. You're in space. But mass is not lost. Weight is lost. Because gravitational pull is not there. You are floating. Got that? So the mass here is 12U. The mass here is 16U. The mass here is 1U. If I say, give it to me in grams, just put grams. The value will not change. Okay? Now, only the unit is changing. Now, what is the value of this U in grams? Value of U in grams is given to you here. Atomic mass of carbon. The weight of one atom of carbon. Atomic mass of carbon is 12, that we know. When we say the 12 or 12U, now we're making grams, atomic mass is 12 grams, correct? What is those 12 grams? It is the weight of 6.023 atoms. That is Avogadro's number. So when you divide both, the total weight upon the number, you get the weight of one atom. You get the weight of one atom. Always remember, the atomic mass divided by Avogadro's number will give you the weight of one atom of any element. Atomic mass upon Avogadro's number. Divide. Now that you have got this number, divide that by 12, the atomic mass divided by that number. Weight of one atom. Weight of one atom. Divide the total mass by one atom and you get the value of unified mass. Correct? So AMU is actually this. For carbon, if it is for oxygen, you will have 16 divided by a different number. Okay? 16 divided by the weight of one atom. That is the formula. 16 in the case of oxygen. Okay? Atomic mass upon weight of one atom. Follow this now? All of you? Okay. Molecular mass, you know. What is RMM? That is relative molecular mass. Mass of one molecule of a substance upon weight of mass of 1/12 mass of carbon C12. Same formula. Only in the case of atom, you are putting molecule. Okay? Now, actually, molecular mass is nothing else but molecular weight. It's nothing else but molecular weight. And if I say, give me the molecular weight of a particular compound, and I don't mention the unit, you will write down U. But if I say, give it to me in grams, Don't write down you, write down grams. For example, I ask you to give me the molecular weight of, say, carbon, sodium, carbonate. Someone says, give me the molecule. This is the molecule, yes or no? Give me the molecular weight. Sodium is what? I will tell you. I will tell you that sodium is 23. I will give that to you in the problem. Sodium is 23. Carbon is 12. Oxygen is 16. Correct? So now how do we find it? It will be 2 into Na. Correct? 2 into Na. That means 2 into 23. Yes or no? Yes or no?
Yes.
Plus you have got 1 into 12. Because there's only one carbon. 1 into 12. Plus, what will I get here?
16.
What is it? 3 into 16. By 3 into 63, and atomic mass is 16. So therefore, you have got 23 into 2 is 46, plus 12, plus 63 is 48. What's your answer? 6. 6, 7, 8, 8 and 8 is 16. Carry over 1, 4 and 5, and 1, 6, 7, 8, 9. 106 U. 106 U. Or I will say, no, I want it in grams. Then you will say 106 grams. Have you all followed this? Who has not understood this? Raise your hands. Who has not understood? All of you have understood it. Now, if you have followed it, then I'm going to ask you one by one to come on the board and give me the molecular mass of certain compounds. Shall I rub out the board? Yes, all of you? Okay, now. Okay, so I'll give you some compound on the board now. Close all your books. Close all your books. Just first one. Correct? Is it correct? Yeah. Correct. Okay. Okay. Next one. Nitrogen is 7, not 14, sorry. I made a mistake. Nitrogen is 7. Change it to 7, sorry. Ah, sodium. Ah, sodium is 11. Sodium is 11. Oh. That is sulfuric acid. One moment, sulfuric acid, no? Hydrogen is move from the way. 2 into 70, 2 into 1. Plus sulfur is 32, no? 32 into 1. Right, plus 64, 68. 16, is it correct? Is it totally correctly? 1,300. What is 130? Okay.
14. 14 has to be 12. I made a mistake here. This is calcium is 40. 20 is your atomic number. We are talking about weight, no? Calcium is 40. 40. This is 12. This is oxygen here. This is hydrogen. This is 32. Nitrogen is 14. So this is 23 and not 19. Calcium is 38.
Shall I resolve it? Resolve.
I didn't what happened?
Shall I resolve it?
Resolve your calcium, no? 40 it should be 1 into 40. So give me 40 now. Let's use our color and the ink for this will be 40. This is 40. 1 into 40. 40, okay. This is okay. So this is 40 and 12. That is 52. 52. 52 and 48, no?
Yeah.
9, 10, 100, correct?
Yeah.
100. Okay, fine. All right, that's fine. This one. So potassium is 38. 38. Okay, and then this is 14. This is okay. This is okay. Nitrogen is 14. 7. No, this is 14. This is 14. So this will change. Okay. This is who did this nitric acid?
This.
You did that.
No, this.
You did it. It has to change. Okay. 1 into 14 plus 63 is 48. 1 plus 14 plus 14 plus 48. That is how much then? 1 plus 14 is 15. 15 plus 48. 5 and 8, 13. 4 and 1 is 5. 63? 63. So it becomes 63. 63. And this is okay. This will be 1. This is okay. So 138. So that will be, it will be what now? 38. 38 plus 14 plus 48. Correct? 8 and 8, 16, 17, 20, 4 and 1, 5, 6, 7, 8, 9, 10. Again 100. Okay, fine. All right. So now do you all know how to do it? Who doesn't know how to do it? You all want to do it? What time? 8:35. I still want to teach you percentage. That's why. I'll leave it here. Okay, we'll do percentages. I'll give you a chance to do percentage. I'll give you. So up to here we have done. Correct? Up here. Go. We are go to your place. This is done. You'll have done that. Now we come to percentage composition. Percentage composition. So this much, all of you have understood, or who haven't understood this much? This calculation, how many of you have not understood? Raise your hands. Molecular weight, all of you understood? Pakka? Now we come to percentage composition. Percentage, what's a percentage composition? Composition. Okay? That was one, there is calcium. Okay. What is meant by percentage? Huh? 100. Composition, that I'll tell you. Suppose you are given a particular compound, sodium nitrate. Sodium nitrate. You are told to find out the percentage composition of sodium in sodium nitrate. And I know the problem. Find the percentage composition of sodium in sodium nitrate. Correct? Okay? That means, in other words, you have to find out about how much of sodium is present in this percentage wise. So what we will do now, don't be bothered about big words. Just remember the simple thing. Find out the molecular weight of this. Tell me how will I find out the molecular weight of this? Tell me what I write here. Sodium nitrate. What is the molecular weight? Tell me how to find it out. Tell me fast. Numbers give me.
23.
Don't. Who opened his mouth? I'm looking at him. I'm cockeyed over. One eye there, one eye here. What is it? Tell me, hurry up.
23.
23.
40.
40, just 40 or plus.
Okay.
I'll give you more. 23 plus
14
plus
16 into 3.
16 into 3. Correct? That means what now? 23 plus 14. 23 plus 14, that is 37. Am I correct? Plus 16 is a 48.
So 7 and 7, 14, 15. 4 and 1, 5, 85. Correct? Am I right? So molecular weight of sodium nitrate is 85. Yes. Correct. So much you followed. Now, remember one thing. This whole molecular weight is here. Now, in 85, this is grams. Huh? In 85 grams of sodium nitrate, how much of sodium is there? 23. Why am I talking about sodium? Because it is stated find the composition of sodium only. Correct? So you talk about only sodium. So in 85 grams of sodium nitrate, 85 grams of sodium nitrate, there are how many grams of sodium? How many grams of sodium are there? 3. There are 23 grams of sodium. Why am I talking about sodium? Because sodium is asked. Okay? If they ask you nitrogen, then you talk about only nitrogen. Therefore, in 100 grams of sodium nitrate, there are how many grams of sodium? Why am I taking 100?
Because it's percent.
They ask you for percentage. Correct? So therefore you find out now, it will be always 100 upon 85 multiplied by 23. Who's got the calculator, your mobile? Fast, give me the answer, fast. How much is it?
27.0.
Pakka?
Yes.
27.05. Okay, all right. So that is the answer. This is the answer. Suppose I tell you find out of every element.
So we have to.
So we take it. We take for nitrogen. So nitrogen is how much? What you say? Can you say 100 upon 85 multiplied by 14? Nitrogen is 14, na? Same. 100 upon 85. That means in 85 grams of sodium nitrate, there are 14 grams of sodium. Therefore, 100 grams of sodium nitrate, there are how many grams of sodium? Of nitrogen. So the same 800 upon 85 multiplied by 14. Give me the answer. Give me the answer. How much? 16.47. Pakka? Now, suppose I ask you to find out of oxygen. Same thing. In 85 grams of sodium nitrate, there are 63 to 48. No, 48 grams of sodium of oxygen. Therefore, 100 grams of sodium nitrate, there are how many grams of oxygen? So again, what will be the last? Give me the proportion then for oxygen. For hydrogen, what will you get? What? You're not paying. Come here and sit here. Tell me how much the percentage you calculate for me for oxygen.
40.
Huh?
40.
Give me this proportion. The statement that I gave you. Give me the statement first for oxygen.
In 85 grams of sodium nitrate, there are 48 grams of oxygen.
That finished? Give me the second part of it now.
100 upon 80.
Therefore, in 100 grams of sodium nitrate,
Therefore, in 100 grams of sodium nitrate, there are 48
there are how much grams of?
oxygen. 48 grams.
48 is here. 48 is here. How can 48 be in 100 also? Have you followed? What? What is happening to you? Did you understand? What you didn't understand? What you didn't understand? When I did these first two, you didn't follow? Did you follow or not? Same thing you do for oxygen. Find out what is the percentage of oxygen in this compound. Tell me, how will I do it? Put the hand off your mouth. How will you find out?
100 upon 85.
Okay. 100 upon 85 into
48.
48. Now, if you give me figures like this, I'll give you one hard slap. I want explanation. You can copy this from somebody. But when you write like this, I know fully well you've done it on your own. Give me statements.
In 85 grams of sodium nitrate, there are 48 grams of oxygen.
Then,
In 100 grams of sodium nitrate,
there are how many grams of
how many
oxygen?
grams of oxygen?
Huh?
Then we have to calculate.
Of course, you think I'm going to sit and calculate by the side? Huh? Kada? What is the answer? Answer fast! 56.47. Okay. Now, if you want to check whether your answers are right, this plus this should give you 100. Should give you, can we check up now? Shall we check up? 27.05, then 16.47 and 56.47. Correct? 7 and 7, 14. 14 plus 5 is 19. Carry over 4 and 4, 8 and 1, 9. Then 6 and 6, 12 and 7 is 19. Carry 1. 5 and 1, 6, 7, 8 and 1, 9. 99.99 is perfect. Because here you may have gone up to 3 decimal places and you didn't give me one number extra. You have to increase it. You have to always work. If you say work up to 2 decimal places, you work up to 3, and if the third one is 5 and more than 5, then you increase this one. Now this you did not do that, therefore you are getting the 0.01 difference. But this is okay. We will allow it. We will allow it. Within the limits of experimental error, we will allow it. How many of you have not understood this? Raise your hands. Can you understand? All of you understood? Which school are you from?
North.
Huh?
North.
Why you're dreaming of the north, south, east, west? What are you dreaming about? What?
Math.
Followed now, all of you. Now read the entire up to there, and then finally we are almost getting done. Finally, we come to what is empirical formula. Huh? Your book must be. I don't know. I didn't steal it. Yeah, I took it. Empirical formula. Where do I write it down now? Empirical formula. Okay. Empirical formula. Empirical formula. And it is given as EF. Empirical formula. The empirical formula is a formula. See, there are 2 formulas of a particular compound. One is empirical formula and one is molecular formula. What is molecular formula? Molecular formula will tell you the exact number of atoms present in a particular compound. Molecular formula. Suppose you have molecular formula. Molecular formula. Molecular formula is MF. It will tell you the exact number of atoms present in a compound. C6H12O6. Okay, that means in other words, this is the molecular formula. It tells you exactly that in carbon, in this glucose, you've got 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. But empirical formula will tell you the simplest ratio of atoms present in the compound. The simplest ratio is 1:2:1. This is empirical formula.
C1
Okay.
H2
Huh?
CH2O.
C1H2O is the empirical formula. And molecular formula, you have to multiply by 2 and you get the exact number of elements. Okay? Exact number of atoms present in the element you will come to know. And molecular formula is always a multiplication of the empirical formula. So suppose you've got H2O2. This is hydrogen peroxide. This is molecular formula. And the empirical formula is HO. Take out the common denominator. Empirical formula will tell you the simplest ratio of the elements present in the compound. Simplest ratio. Molecular formula is the formula that tells you the total number of atoms present in the compound. H2O. H2O will just remain 2:1. Both of them are prime numbers. Come down to prime numbers. When you have to calculate empirical formula, come down to prime numbers. 2 is a prime number, 1 is a prime number. Finish. Here, empirical formula and molecular formula is. Okay?
One is not a prime number, not a composite.
Huh?
Prime is not a prime number, not a composite.
Who?
One.
Garab, you don't talk about maths to me because I don't know anything about maths. I only know that 1 is a prime number. Followed? Go and sit in the back there. Not quite fool. Foolish fool. You're trying to make me mad. Where's the cover? You don't go to the toilet today? Read! And all the equations in that book, I want you to balance and show me. In the book itself, you can use that textbook as your workbook, but use pencil and balance those equations in the book. Let me see your homework. Come on. Have you done it now? Do you know that? Yeah. Every day you just give a look at it. You're registered in your head. Very good. Very good. You got something here. Who have you done on your own? Or you? Very good. Very good. Let me see yours. Very neat. What about this? Don't do it this year, next year. Take 1 full year rest and then do it. You? This is not enough. This is complete. This is what is complete. This is not right. Let them complete what you. Yes, your dog ate it, your cat has eaten it, or somebody has made a mess on it, converted it into a toilet paper. You? This is not complete. This is not complete. You think I don't know? I will not come to know? You think I'm an idiot? Where's your work? Show me your work. Why I have to do books? This handwriting is shabby. Just look at that girl's book. Give me a book. Very shabby. It's okay for you to write on an ink, in print. But if you're trying to write on learning hand and you're giving this book, I'll swing this book out of the window. And if I were if I'm an examiner, I will refuse to check this book. It's very untidy. It will irritate me and I'll give you 0. Do not irritate the examiner. Never do that. This is also incomplete.
No,
It's not complete. It is incomplete. Show me your work. Huh?
I didn't put the things, but I read 60%.
You come home with me tonight. I'll teach you food, yes.
Okay. I can this.
Yes. Where's my book? Somebody ran away with my book. Will someone rub it? You rub it. Please, huh? Right. Tomorrow are you coming to English? Please bring your laptop and a pencil. Okay, all of these. Either painting, no. Those are it. I want the textbook and the pencil. Don't come to that. Just you know.
Okay, where is the street?
He said Mongo Baba
You started.
in school.
You guys. Crazy. In the street. In the street, bro. Just in the street. I'm not in the street. Good job. I'm not in